All right, I'm recording, guys. So, in order to perform a hypothesis test, you have to perform 5 steps. The first step, so let me write them down. 5 steps. Always those 5 steps. The first step is to state HO, and what else, guys?
HA.
HA. And one more thing you have to do also. State HO, HA, and identify what?
The claim.
The claim. Very good. You have to know where the claim is in HO or HA. Okay. Number 2. You have to calculate or find what we call the test statistic. Which is Z. It's going to be T later, but for now, it is Z. This is by converting the X bar, the sample mean, to a Z score. That's what you learned in chapter 2. And we've been using this formula, guys, as you notice. But on the calculator, you don't know what you're using because it's done for you. That's step number 2. Step number 3. Find a p-value. That's the most important one here. Usually the p-value is rounded to 4 decimal places. Number 4, make a decision. To reject HO or fail to reject HO. You need to memorize this, guys. How do you reject or fail to reject HO? If we will give you level of significance alpha, that will be given. This is the maximum allowable probability of rejecting the null hypothesis when it is true. This is the maximum allowable probability of making a type 1 error. Okay, how do you reject or fail to reject the null hypothesis? If p-value is less than or equal to alpha, you reject the null hypothesis. If, just do a comparison, guys, with the two numbers. If p-value is more than alpha, fail to reject.
Would you mind moving your paper up?
Yeah. Fail to reject HO. That's step number 4. This is calculator. This is calculator. This is, you have to do the work here. You have to know how to state the null and the alternative. This is an easy step. You compare the p-value with alpha. If p-value is less than alpha, you reject HO. If p-value is more than alpha, you fail to reject HO. You need to know this by heart, guys. This is very, very important step. And step number 5, write your claim in words. So you have to express your claim in words. And this is what we're going to learn today. We have to do some practice to learn how to do this. So without any further ado, let me just take you to an example and show you how to complete those 5 steps. Have your calculator ready, guys, and I'm going to show you how we can do this using technology. Okay, here's an example. These are the types of problems you're going to see from chapter 7 mainly, guys. It's all word problems. See, I put already the steps there just to guide you through it. So according to a study, the mean cost of bariatric weight loss surgery is $21,500. You think this information is incorrect. Okay, how would you state the null and the alternative hypothesis? Usually, guys, the first sentence or two will give you a clue of how to state the null and the alternative. They say the mean cost of a weight loss surgery is 21,500, but you think this information is incorrect. So it's you who's making a claim that the information is incorrect. How would you say HO and HA? There you go.
HO.
Mean. It's about the mean. No proportion, guys. It's either
Oh,
mean or proportion. So it's mean. Okay, what do you put in HO and what do you put in HA? Anything that has to do with numbers other than percent.
is greater or less than 25?
But they say is. What does is
Oh, equals.
equals? You see, that's the clue, guys. And if you think this is incorrect, what would be the total opposite of it?
Not equal.
And the claim is you think this information is incorrect. That means the claim is what you think. We're not saying that your claim is correct, but this is where the claim is. Any questions about the first step? Yeah, I got some answers in the chat. Feel free to participate with me in the chat, guys. I do check the chat as well. All right, let's continue reading now. You randomly selected 24 patients. So N is 25. Watch, guys. And find that the average cost for their surgery is 20,695. That's X bar. The population standard deviation is known to be 2,250 sigma. Once he gives you the population standard deviation, guys, you know you're stuck with a Z test. And I've gave you a hint here. Probably that won't happen on the test, but you know that must be a Z test here. When he gives you sigma, take a note here. You must perform a Z distribution, which is on the calculator is interpreted as Z test. And the population is normally distributed. Some students confuse the wording that the population is normally distributed, that they say that this is sigma. No, all populations must be normally distributed, bell-shaped. So it's a condition for most of the exercises that we do, unless if the sample size is more than 30. Is there enough evidence to support your claim at alpha equals 0.05? You see, this is the level of significance. Alpha is 0.05. And when do we use alpha, guys? We use it in step number 4 when we compare it with the p-value. So we're ready. Step number 2 and step number 3. Let's put them into the calculator. So clear. And I want to walk you through this. So you go to stat. I'll go step by step. Watch, guys. Z test, it's the first test. Section 7.2 is the first test under tests. Input, if you have a data, you use data, but I have a summary here, so just use stats. Okay. Let me remind you again. The first value, it's called what's the value that you assumed that it is true in the null hypothesis, which is 21,500. Sigma, which is 2,250. X bar, 21,695, if I'm not mistaken. Yeah, 20,000, sorry. N is 25, guys. Okay, let me tell you what this one is. This is what sign do you see in the alternative hypothesis? You must select that. You forget to do that, you're gonna get wrong answers. What is positive is going to become negative. What's negative is going to become positive. It's going to be a big mess here. So you have to make sure that you put the correct sign. What is the sign in the alternative hypothesis, guys? It's not equal. You must select it. No, it doesn't seem like it's selected before I hit enter. So I have to hit enter. Now it is selected. Okay. And then you hit calculate or draw. It's up to you. Let me do a draw here. If I do a draw, you're going to see the p-value on both sides of the equation. If it is a big p-value, watch. What's being shaded is the p-value. Okay, and you see what's z? Who can give me the z value to 2 decimal places? Online, you'll be asked to round z to 2 decimal places. So this is what? -1.79. Yep. And the p-value, read it carefully, guys. What is this? Yeah. It's given 4 decimal place, so that's nice. 0.0736. Okay. Step number 4. Bring alpha down to the plane now. Okay. Do you guys agree with me that 0.0736 is bigger than alpha, which is a 0.05? And look how I compare, guys. This is easy to compare. 0, 0, they're the same. Decimal point, they're the same. 0, second 0, second 0, they are the same. Now, second digit here, 7. Second digit is 5. 7 is bigger than 5. That means the whole thing is bigger. So p-value is bigger than alpha. And what's the decision? If the p-value is bigger than alpha, what do we do, guys? We fail to reject the null hypothesis. Fail to reject HO. Okay. Look, guys, step number 5 now. So step number 4 is easy. If the p-value is bigger than alpha, you fail to reject HO. If the p-value is less than alpha, you reject HO. Now, you cannot reject HO. So we're saying this is probably not bad. Probably it's good. If the first one, guys, is not bad or it is good, that means you cannot support the second one. So since we fail to reject HO, look, how do we start? Every time you have the fail to in step number 4, you have to start with there is not. You can link the two, guys. I'm going to show you. Always, if you have a fail to reject, you have to put not here. These are linked together. If it is a reject HO, you say there is without the not. There is not enough evidence. Just like in the court of law, enough evidence at the, what's the level of significance? 0.05. Level of significance to support. He asks us, is there enough evidence to support the claim? We're telling him there is not enough evidence to support the claim. To support the claim that the cost of weight loss surgery is different from 21,500. We cannot say it is different. We could not prove that. That's how you state the conclusion, guys. So again, you fail to reject HO, you put there is not enough evidence at the 0.0 level of significance. We use the word support when the claim is in HA, so we're saying we cannot support the claim. That means HA probably wrong, it's not true, and HO probably is the good one here. We usually try to go against HO, but we failed here. How do you fail? Because we failed to reject HO. So you kind of accept it. We don't say, as I told you, we don't say that we accept HO, but we don't have enough evidence against HO. That's why we end up not being able to support the claim. So the only way, guys, if you have a claim in the alternative hypothesis, the only way to support it is to be able to reject HO. So you do whatever it takes to be able to reject HO, then you will be able to support the claim if it is in HA. But if you don't reject HO, you have to say that there is not enough evidence. Don't forget the up to 0.0 level of significance to support the claim that the cost of weight loss surgery is different from 21,500. When you do your work in my math lab, you're going to see a drop down menu with there is or there is not. So you choose there is not. Then you're going to see another drop down menu. It says to support or to reject. You're going to choose support because the claim is in HA. Anytime the claim is in HA, you choose the word support. And then you're going to see a drop down menu that picks up the claim you just selected, and that will conclude step number 5. Any questions about this example, guys? Let me see if we have anything in the chat. No, we're not saying it probably correct. We're saying probably wrong. We say we cannot support it. If I cannot support, let's say you make an argument with me. If I tell you I cannot, you're not giving me enough evidence to support you, that means I'm not supporting you. So every time you see the word no, that we're not supporting this. That means this probably is good. That means the cost of surgery did not change. It's still 21,500. That's what we're trying to say. But we don't speak in favor of HO or not. We just speak in favor of what the claim is. We just follow the claim. He's telling me that the cost of surgery is not 21,500. I said, well, I don't have enough evidence to support your claim. That's what we're trying to say here. Okay. We're going to do a few more so you guys will have a better feeling. So it's recording now. An expensive restaurant claims that the average waiting time for dinner is approximately 60 minutes. They say you have to wait about 60 minutes to get a table. But we suspect that this claim is inflated to make the restaurant appear more exclusive and successful. You know, guys, when you hear about a place that you have to wait 60 or 90 minutes, you're going to think big of this place. You're going to think, oh, wow, that must be a very good place because everybody has to wait to get a seat. So how would you state the null and the alternative? We suspect that this is inflated. So the 60 minutes, we suspect it's too much. How would you state the null and the alternative? What do we mean when we think it's too high, or is there evidence to say that the restaurant claim?
Would we say the greater, equal or greater than?
Yeah. Okay. It's a page 19 in the handout. So if we think that, so we don't believe him. We don't think it's 60 minutes. We think it's less than 60 minutes. Do you guys agree with me? Because we're saying they're inflating. When you tell somebody you're inflating your numbers, that means you're giving me numbers too high. That means your number probably are lower, a lot lower. So we think that actually the mean is less than 60 minutes. That's the claim. Sometimes he gives you the claim in a straight inequality, and other times he just puts some simple English words and wants you to interpret that. When you say it's with is there evidence to think that the restaurant's claim is too high? That means it should be lower. That's what we think. When I say it's too high, that means probably it is lower than what you're telling us. That's what we say. So can you guys tell me what you said now about HO is correct? That's the opposite. And our claim, we want to prove, we think that the restaurant claim is wrong. and we think that the wait time is not 60 minutes, it's less than 60 minutes. That's our claim. Now, maybe some students will say, well, they say is 60 minutes. That's their claim. In the question, you have to follow what you want to study. Who's making the claim? If we were doing the restaurants the claim, then it will be equal, not equal. That's what, but then we're not verifying their claim. We're verifying you. You suspect that this claim is inflated. A random sample of 32 customers. So N is 32, guys. Yielded a sample average waiting time of 50 minutes. Here you go. We survey 50 customers. We watch them, and on average, they waited 50 minutes, not 60. The population standard deviation for waiting time is to be seated at a restaurant is known to be 10 minutes. So sigma is 10. You see, how do you know it's sigma? Because it says a population standard deviation, which is sigma. Is there enough evidence to say that the restaurant claim is too high? He didn't give me alpha. If he doesn't give you alpha, guys, use 0.05. So I'm gonna just use 0.05 here. I usually give it in the book. You will have it also, but if you don't see it in a problem, assume it is 0.05. We already stated the step number 1, HO and HA, so that's good. Just remember, guys, in HA, you can have only those signs. These are HA signs. And in HO, you can only have those signs. So don't mix them up. This is HA, and this is HO. And those signs come together like that. These two together, these two together, and the last two come together as well. Okay, so now we're gonna go to z-test and get the results. Let's go to the z-test and get step number 2 and step number 3. Z-test. Ready? So mu0, it's against the 60 minutes. See, the null hypothesis is called the status quo, the previous belief. The belief that it is 60 minutes, that people have to wait 60 minutes. Now we're going against this traditional old belief and want to see if this belief is still good, or probably we can defeat it. That's what we're trying to do. So sigma is 10. X bar, guys, is 50. N is 32. And then, can you tell me which sign do I select here? First, second, or third?
Second.
Second, very good. Does everyone agree with what she said? It's the second one, because this is the sign in the alternative hypothesis. Even if it's blinking on the second one, make sure to select it and press enter, because it is possible that another one is selected, but you move the cursor to that one, but you do not select it. So just make sure to do that. And now, guys, if you like to do a draw. Okay, if there is a p-value, it's going to be on the left now. So if the p-value is large enough, you will see a shading on the left. Watch. Why on the left? Because this is a less than. Less than, the p-value will be on the left. Greater than, the p-value will be on the right. And not equal to, the p-value will be on both sides. There you go. Oh, it's a small, it doesn't show. Oh, it says almost 0. So can you read the test statistic for me? 2 decimal places. So that will be -5.66. Yeah. And p-value is almost 0. Just put this as a p-value. It is 0. That means it's less than alpha. I don't need to know what alpha is because it's so small.
I have a question.
Mm-hmm.
On my calculator, because it's the older one, the p-value came up as 7.73015, but it did have the exponent with the -9.
Yeah, let's interpret it.
So that means
Give it-
9 zeros before the 7?
No, that is correct. So give it to me. What did you get? 7
I
point.
had 7.73015 with the exponent -9.
Yeah, no problem. Let me tell you, you guys don't ignore the e -5, -9 here when you write the answer. Look, it means that you have to move the decimal 0.9 digits to the left. If I
Okay.
move the decimal 0.9 digits to the left, I need to put 8 zeros. So here is your number. Forget about this. You see? 0.000000007. Well, we want only 4 decimal places gonna be 0. Does that make sense? That is the p-value. Okay. If the p-value, look, just try to remember this slogan here. P-value low, HO must go. It means if the p-value is less than alpha, you reject the null hypothesis. P-value low, HO must go. That's less than alpha, we reject HO. There you go. And now, how do you write the conclusion? You don't put there is not here because you rejected HO. You only put not if you fail to reject HO. There is enough evidence at the 5% level of significance Okay. Where is the claim, guys? In HA or HO? In HA, correct? If the claim is in HA, you use the word support. So there is enough evidence at the 5% level of significance to support the claim. That the wait time is inflated of 60 minutes. That means the restaurant claim is wrong, guys, is too inflated. Or you can put it that the wait time is less than 60 minutes. There you go. You proved that the restaurant claim is wrong. This study, guys, is valid enough to go back to the restaurant and show it to the restaurant manager and tell the manager that you're misleading people because we did a hypothesis test and we verified that your claim is not is not valid. He might question your sample size or how you picked the sample. If you can convince him that you picked a random sample, then this is an evidence, guys. That's what we call evidence in hypothesis testing. So that means it's a false advertisement. That means that they're misleading people into believing that this is very fancy restaurant because of the wait time, but the actual wait time is actually less than 60 minutes, and we were able to support that. Any questions? A manufacturer of sprinkler systems designed for fire protection claims that the average activating temperature is at least 135 degrees. Okay, can you guys help me state the null and the alternative? So page 376, number 32, and what is HO and what is HA? It's all about numbers, so that means average means mean. So guys, this is the clue. You should put mu and mu here. And what does at least, what's the sign that you use for at least, guys? What's at least? Yes? How do you write at least? That's very important. If you don't know how to do that, then it's going to be a trouble. You won't be able to solve this problem. So do we agree on at least?
Less than?
Not at least. Not equal or less than. It's equal or
Greater.
greater. Yeah, that's at least. So you guys agree with me that it will turn out to be in the null hypothesis because it has a greater than or equal to, that's a null hypothesis sign. That's 135. And this is your claim. That's the claim. And what would be the alternative? What's the opposite of this statement? Yes? Less than.
Smaller than.
Yeah. That's it. That's how you state the null and the alternative. So at least, guys, for your information, it's a null hypothesis sign, greater than or equal. At most, also a null hypothesis sign, less than or equal. You put it in the null hypothesis. Okay, let's continue on reading now. You randomly select a sample of 32 systems. So N is 32. And find the mean activating temperature to be 133 degrees Fahrenheit. So X bar is 133. Assume that the population standard deviation is 3.3 degrees Fahrenheit. At alpha equals 0.10. So alpha is 0.0. Do you have enough evidence to reject the claim? I have a question for you guys. In the previous two questions, he asked us if we can support the claim. And here he's asking us if we can reject the claim. He cannot ask us if we can support the claim. He says, would you be able to reject this claim? Why did he say that? Where is the claim, guys? Is it in the null or the alternative? Do you agree it is in the null hypothesis? When the claim is in the null hypothesis, we try not to support it. We try to decide whether we can reject it or not. We don't use the language of support. You only use the language of support or not support when the claim is in HA. So remember that, guys. When your claim is in the null hypothesis, you either make a conclusion to reject this claim or fail to reject this claim. So we don't use the word support. And let me show you how we're going to write a conclusion once we do the steps. So this is the first step. The second step is a calculator step. Let's do it. Clear. All right. So stat, tests, z test. Mu0 is 135. That's the value in the null hypothesis. What did he say? Sigma is 3.3. X bar, he says it's 133. Sample size is 32. And which sign do we use here? We use this sign here, right here. You have to select this one, guys. Okay, let me say go and press enter. Okay. I like to draw so you can have a visual of the p-value. Oh, must be very small. Okay. So negative 3.43 for Z. And p-value is, who can interpret the p-value using a decimal? It says a 3e minus 4. You have to move the decimal point 4 digits to the left. It is already 3 point. So what would that be, guys?
It'd be 0.00003.
No, the 3 zeros and 3, because 3 is one digit and you need 3 more zeros. So that's the p-value, which is less than alpha. You guys, when the p-value has an e in it, right away put it less than alpha. It's going to be very small. Alpha is 0.10. So we reject the null hypothesis. And why we reject the null hypothesis? Because the p-value is less than alpha. Okay. How do you write the conclusion, guys? Watch. You write, there is enough evidence at what level of significance? So at the 0.10 level of significance. You can put 10% also if you want. Okay, if you're using my math lab, it's gonna give you a drop-down menu to choose reject or support. Look, guys, your claim is an HO, and you rejected HO. You just said, I'm rejecting HO. That means you reject the entire claim. When you reject the null hypothesis, and the claim is a part of the null hypothesis, that means you reject the claim. So when the claim is in the null hypothesis and you reject the null hypothesis, you say there is enough evidence at the 0.10 level of significance to reject the claim. And write it down. That the average activating temperature, I'm just copying and pasting the words, guys, is at least, of a sprinkler system, is at least 135 degrees. And that's very serious, guys. When they say it will pick up, just when it is 135 degrees, the sprinkler system, just will go off, and we're saying that this claim is wrong. That's very serious because that's very sensitive as far as safety here. So there is enough evidence at the 0.10 level of significance to reject the claim of the manufacturer of the sprinkler systems that the average activating temperature is at least 135 degrees Fahrenheit. Any questions here? And guys, if you don't want to do the visual here, you could have done this. Let me show you. You could just go to Z-test and stat and just hit calculate. There you go. So you get the same values. Now look at the p-value. Just move it 4 decimal places. You will get 0.0003, which is less than alpha. Remember, alpha low, p-value low, HO must go. A school publicizes that the proportion of its students who are involved in extracurricular activities is 61%. We did that. Is means equal, guys. And that's a P now because he's using percents now. So that's a 61%. And that's not 61%. And the claim is right here in the null. Okay, is this a left tail test, right tail test, or a two-tail test? What do you guys think? He wants to know, is it a one-tail or two-tail test? Okay. Two-tailed, yes. Because it has not equal to. When it is not equal to, guys, it's a two-tailed test. And he wants you to show how the p-value would be like. Here's how you show it, the p-value, guys. Just do this. And the p-value will be two tails. Shade something on the left, shade something on the right, and that's your p-value. So p-value is doubled. For example, if this is a 3%, then it'll be 3%, and 3% will be 6% total. Because it is two-tailed. Okay, let's do number 2. A car dealership announces that the mean time for an oil change is less than 15 minutes. Less than 15 minutes, guys, you agree it should be in the alternative, and that's the claim. And this one will be greater than or equal to 15. Okay, one-tailed or two-tailed test? What do you guys think?
One.
One tail, left or right? If it is one, it has to be left or right. This is less than. Less than, we're going toward what? The left or to the right, guys? This way.
Less or to the left?
Yeah. That's a left tail test. And look, how do you show the p-value? P-value will be an area to the left. And actually, this is the z-score. This is the test statistic here. That's the p-value. All right, let's do the third one. A company advertised that the mean life of its furnaces is more than 18 years. More than, guys, means area to the right. So, to the right. And this is less than or equal to 18, claim. And if you want to have a visual of the p-value, here is the p-value, watch. That's the test statistic z, and it's an area to the right. That's the p-value. That's always a 0 here. In the center. And we use the z line always. In this chapter, it's z. It's all about z in this section when sigma is known. Okay. And now, guys, how do you state the conclusion? I'm going to show you the 4 scenarios. If you try to memorize those 4 scenarios, you will never go wrong with writing the step number 5. So you get the p-value. You compare it with alpha. If the p-value is less than or equal to alpha, you reject HO, and the p-value bigger than alpha, you fail to reject HO. How do you state your conclusion? If your claim is in HO, in the null hypothesis, and you reject HO, then you state that there is enough evidence to reject the claim. So when the claim, guys, in the null hypothesis, you use the word reject. We didn't put there is not enough evidence because you rejected HO. When you reject HO, you don't use the word not at all. So there is enough evidence to reject the claim at the alpha significance level. Whatever alpha is, you put it. 5% significance level, 10%, 1%, whatever it is, you just put that. So this is the first scenario, guys. Now, if the claim is in HO and you don't reject HO, you fail to reject HO, what do you say? Okay, since this is a fail to, what do I start, guys, saying that there is what? Not enough evidence to reject the claim. Remember, not is linked to fail to reject HO. So if step number 4 is a fail to reject HO, you say there is not enough evidence. 2, as I told you, you have to decide between the word reject and support. If your claim is in HO, guys, you use the word reject. If your claim is in HA, you use the word support. So these are the 2 scenarios when the claim is in the null hypothesis. Now, these are 2 scenarios when the claim is in the alternative, which is the common case, guys. Most claims should turn out to be in the alternative. If the claim is in the alternative and you reject HO, then you state there is enough evidence to support the claim. And can someone tell me what's the last one is going to be? If the claim is in HO and if HA and you fail to reject HO, what do you say? Fail to. It will be exactly the same as this statement, but one word must be added. There is not enough evidence to support the claim. I mean, this word makes a big difference. It changes the statement from a yes to a no. There is not enough evidence to support the claim. So as you can see, guys, we never confirm a claim 100%. There is no such a thing called 100% in statistics. You say there is not enough evidence to support the claim at the alpha 5% level of significance. There is enough evidence to support the claim at the 5% level of significance. The 5% means there is a possibility that you guys rejected the null hypothesis when it was true that you made a mistake, you made a type 1 error, so it is possible.
Could you go over the keywords again? I'm sorry, you said if it's in the HO, the claim is in the HO, like
You're
the,
either gonna have to use the word reject or not reject. So if the claim
no, I
is
mean,
in
like you said,
HO
it would be in the statement. The
Oh,
keywords
yeah.
in the statement.
Yeah. So look, guys, let me just do the scenario one more time because this is very, very important. If you guys can comprehend those 4 bullet points, and you will know how to write the conclusion of any claim. What I'm trying to say, guys, let's agree on this. If the claim is in HO, your claim is in HO, you write one of 2 statements. If you reject HO in step number 4, you write there is enough evidence to reject the claim. Can't write both at the same time. It's only one. You have to select one. And if you fail to reject HO, do you guys agree with me that when you make a decision, you're either gonna reject HO or fail to reject HO? You're not gonna get both at the same time. That's impossible. So it's either this or that. If you get this, you say, I have enough evidence to reject the claim. The claim is bad. If you fail to reject HO, you say, I don't have enough evidence to reject the claim. There is not enough evidence to reject the claim. That's it. It's one of the 2. If the claim is in HO. Now, guys, if the claim is in HA, look what you shall write. So this is the first 2 scenarios. Now, if claim is HA now, look at the word A here, it's not 0. Okay, you have to make one of 2 statements. If you reject HO in step number 4, you say there is enough evidence to support the claim. And now why we're using the word support, not reject this time? Because I rejected the first one, guys, which is HO, and my claim happened to be in the second one. That means the second one is good. If I tell you guys, you bring me 2 assignments, and I'll tell you I'm gonna accept one of them. If I tell you I'm rejecting the first assignment, what does it mean for the second assignment? It means it's accepted, it's good, that's it, done. Because I said I'm gonna take one of the 2. So the first one I say is bad, then the second one must be good. That's what it says here. You reject the null hypothesis and your claim happened to be in the alternative hypothesis. That means your alternative is good to support. There is enough evidence to support the claim. And if you fail to reject HO, guys, you say, instead of there is enough evidence, you say there is not enough evidence to support the claim.
So those are the keywords, like, again, the support. If we see support, that pretty much gives us, like, in the actual
100%.
that will tell us
100%.
that it's in
You
the HO
don't-
or the
Yes.
HA.
Yes.
Claim.
You don't need to see the word support. All you need to know where the claim is. If your claim is in the alternative, you use the word support. Don't try to use the word reject in the last statement. And if your claim is in HO, you use the word reject in your final statement. Don't try to use the word support.
But wouldn't it, if the question says, do you support or whatever, isn't
That's
that
it.
like
That
a clue
means
that the
that
claim
means
is
the
in
claim.
HA?
Yeah, yes, 100%. That's a very good statement. If he asks you, is there enough evidence to support the claim? Be sure, guys, the claim must be in HA. And as you notice in this exercise I just did, number 32, he says, can you reject the claim? That means the claim was in HO. So that's a clue for you guys to know where the claim is. He will not ever ask you to support the claim that was put in HO. He will not. That shouldn't be the case. There will be a mistake to ask this question. So if the claim is in HA, they will ask us whether we can support it or not. If the claim is in HO, they will ask us whether we can reject it or not. So we always try to go against HO. That's why, guys, we don't use the language of support in favor of HO. We try, to say HO is bad, although we can't verify that at times. And when you say, guys, I fail to reject something, don't say that you accept it. Just keep it as fail to reject. Okay. Let's continue. So that's this page here, 6. Let me. 7. Okay. You perform a hypothesis test for the following claim. How should you interpret a decision if you reject HO or you fail to reject HO? Okay. That's what I've been talking about. So let me show you how we interpret that. A school publicizes that a proportion of its students who are involved in at least one extracurricular activities is 61%. So HO will be P is 61%, and HA will be P is not equal to 61%. And guys, you agree with me that the claim is in HO. You see, the claim is in HO. You cannot use the word support now. If you reject HO, what do you say? You say there is enough evidence to reject the claim. And you just copy it and paste it, whatever it is. And can someone tell me what do I say if I fail to reject HO? Yes?
There is not enough evidence.
Yeah, there's not enough evidence to reject the claim. So probably it is valid, but we don't accept it. You see, when they say that defendant is not guilty, that doesn't mean it's innocent. So don't make the conclusion right away it is that the defendant is innocent. So there is not enough evidence to reject the claim. Okay, here, number 2. A car dealership announced that the mean time for an oil change is less than 15 minutes. Greater than or equal to 15. HA, mean is less than 15, and that's the claim. Now look, the claim is in HA, so we have to use the word support. Don't use the word reject anymore. If you reject HO, what do you say? You say there is enough evidence to support the claim. There are no other scenarios other than those 4, guys, that I'm listing right now. If you fail to reject HO, what do you say? There is not enough evidence to support the claim. And where did the not come from? From the fail. Fail means you start with not here. All right. That's this. These are the 5 steps, guys. State the null and the alternative hypotheses. Calculate the standardized test statistic. Calculate the p-value. Make a decision to either reject or fail to reject HO. Interpret your decision in words in the context of the claim. Okay. As I told you, if you have a left tail test, the p-value is the area in the left tail. If you have a right tail test, the p-value is in the area in the right tail. If you have a two-tail test, it's twice the area. You take the right and the left and add them up, or you take one area and multiply it by 2. So that's the p-value. And I'm going to show you how to find the p-value using some different techniques. Find the p-value for a left tail test, hypothesis test with a test statistic of z equals negative 2.33. Okay, let me show you what the p-value is here. Okay, he said in step number 2, you get z equals negative 2.23. What is the p-value? Let me show you how to. So This is 0, always the center. This is the Z line. And look, negative 2.23 is right here, guys. The p-value, because it's a left tail test, it's an area to the left. This is the p-value. Do you guys still remember how to find this area using chapter 5? How do I find the p-value? What function do I use? If I give you this question on the test next week, find the area to the left of negative 2.23, z equal negative 2.23. What do you do to find it? Yes? We forgot. That's a part of the test next week. It's an area to the left of negative 2.23. So you go to normal CDF. Okay, what's the left bound here? What do I use for this? Negative million. Then negative 2.23. Then 0 and 1, guys. Paste. And that's the p-value. 0.0129. Okay, can we reject HO here, guys? Compare it with alpha. What do you guys think? Is p-value bigger than alpha or smaller than alpha? Can someone answer this?
Bigger?
Bigger than alpha. If it is bigger than alpha, you fail to reject HO. Because look, 0, 0, 0, 0, 1, 1, 2 here, the third digit, I have no digits, that means it's 0. So it's bigger. Okay, let's do this one. Find the p-value for a two-tailed test with test statistic of 2.14. Let me show you how to find the p-value by hand. I mean, with the z-test, you can get it, but this is a two-tailed test. You're gonna have two tails. This is the 0 here. This is the 2.14. And if you ask me what z here will be the total opposite, negative 2.14. But you guys can have only this area and multiply it by 2 because it's two-tailed test. Okay, how do I find this area here? You do normal CDF. 2.14 is the lower bound, a million is the upper bound, and then 0 and 1. Let's see. And then we multiply this answer by 2 because I have two shaded regions. It's a two-tailed test. So watch, guys. Second distribute. Normal CDF. When do you use the normal CDF? If he doesn't ask you to perform a test, it just asks you a question like this. But usually you're going to get the p-value out of the test. 2.114. And this is the upper. Put as many 0 as you want. It doesn't matter, guys. 0.0162. So p-value will be twice times 0.0162. Because you have a 0.0162 here and 0.0162 there. If I multiply them, guys, by 2, I get 0.0324. And would you reject HO or fail to reject HO? Alpha is 5% here. What's your decision, guys? Compare these two, this and that. What's the decision?
Fail to reject
Why is that?
because the p-value is bigger than
No,
alpha.
is it?
Oh, no, sorry. Oh, I was going off of the 1 again.
Okay.
The 0.01.
So it's less than alpha, so we reject HO. All right. And the formula for the test statistic, guys, we say it's X bar minus mean divided by sigma over square root of n. That should take care of the missing details Now, will you use this one? Yeah, if you do your work by hand, you will use it. If you don't do your work by hand, you won't use this one. You'll be able to use technology almost throughout the entire chapter. So in conclusion, guys, we will use the z-test to perform a hypothesis test about the mean when sigma is known. What do I mean by the word known? It's stated in the exercise. He says explicitly that the population standard deviation is, then you are stuck, guys, with the z-test. Now, when sigma is not known, that would be the subject of the next section.